So if your UCAT is approaching over the next couple of months, you're going to have to encounter some QR questions. So what I'm going to do is I'm going to take you through some questions that I'm going to do from the official UCAT Question Bank on the website, and you can watch how I do the questions and see if you can take anything from it. And I'm going to start just now. Ready to begin the exam. Okay, question 1, tax. As if you've watched my UCAT Quantitative Reasoning section, skip tax. So the Alt F for some reason isn't working on my keyboard, so I'm going to flag it straight away. As soon as it comes up, I'm not even reading it. Flag, 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 go away. Right. And the whole. So again, if you've watched the video, read the sort of thing at the top. So some information about purchasing land. So prime farmland, 7,500 per acre. Building land is 1.1 million per hectare, and the table shows the costs in thousands of pounds of hectares. To be honest, I would skip this as well. Yeah, no, I'm skipping this. So flag again, so you can come back to it at the end if you've got time. Like honestly, your mindset should be, there's going to be easier questions. This is difficult, I'm not doing it. Just skip everything. Right, this is what I mean. So you can skip questions like this that have previously come up that are really difficult, that are wordy, they've got tables, tax questions. Just skip them, honestly. Like, I know you feel guilty doing it, and I know you feel like you should be able to do it, but just skip it. Like, you can do questions like this so much easier. So velocity versus time. If you've done some quantitative reasoning practice, you probably will have seen like questions like this quite a lot, so you'll be getting familiar with the formulas. So how much greater is the acceleration of car A than car B? Right, straight away we can see that on the velocity, car B's got a straight line, so there's going to be a 0 in this equation. So we've got given the equation here, acceleration is change in velocity, so delta V over change in time. So straight away with car B, we see that there's 0 change in velocity, so it stays at 8. So then the change in velocity is going to be 0, obviously because it's remaining on 8. We don't write 8, it's a change in, so it's just a 0. And the change in time is going to be 4 seconds. Anything with 0 in a division section is just going to be 0. So we can assume straight away that whatever the change is in car A, that's going to be our answer. We can see here that the change in velocity goes from 0 to 16, so we still use this formula if we're given A equals delta V over delta T, so change in velocity over change in time. We can see the change in velocity is going from 0 at the bottom to 16 at the top, so then we've got a change in 16. Then we can see the change in time across the x-axis of the graph along the bottom is 4 seconds. So we've got 16 over 4, we don't need the calculator for that, it's 4. The units are meters per second, so it's going to be A. Let me check the answer, it's A. Okay, so questions like that are ones that you do want to be doing. It's an easy 1 mark and you should be able to do it relatively easy, okay? Next question, again this looks easy, this is why we skip questions. This could be the last question out of the entire exam. If you went through every single question, you could be missing out on something like this. So the graph shows Linda's score in her 4 project years at university. Yep. So she got 98, 92, 97 and 89. So in her second year she got 99 in a 5th project. What's the difference between her 5th score and the average between her first? So we basically have to find the average. So straight away, I wouldn't be writing anything down for this. You press Alt C, you get the calculator up. We've got 98 plus 92 plus 97 plus 89. We've got 376 divided by 4 to find the average. We've got 94. And then for year 2, we have a score of 99. So we know that the difference is going to be 99 minus 94, which is 5. Correct answer is D. This is what we want to be answering. Okay, this one looks a little bit more difficult, but I'm going to give it a time of day just because it doesn't look that wordy. So minerals, mineral water is classified on the basis of the amount of dissolved solid minerals. The chart shows the code. Like, you don't need to read much of that, to be honest, because you can tell by skimming it that there's no sort of numbers in it, there's no values in it. What fraction of the total number of bottles sold at the store with TDS greater than or equal to 50 have the code 4? Right, so TDS 2, 3 and 4, because TDS 1 is less than 50. So what we're taking into account, what we're essentially doing is we're going to have to find the total number of TDS 2, 3 and 4. So then we'll bring the calculator up, we'll do 83 plus 37 plus 30. So then we've got 150. This pen's running out. We've got 150 on the bottom, and on the top, what's it asking us? have the code TDS4. So then we look under the TDS4 section, which is the bottom line in the table, and we have 30. So then we've got basically the easy sum of how to simplify this fraction. 30 over 150, straight away we can divide by 10 to 3 over 15, and then we can divide by 3, and we can get 1 over 5. Yeah, 1 over 5, yeah, B. Yeah, so it's just like that. The sort of easier questions like this you should be able to answer relatively easy. Right, again here we've got sort of a table question, but it doesn't look too wordy, so I would take it on and I would give it the benefit of the doubt. We've got coin A, coin B. If both the coins are made of only nickel and copper, what's the difference between the weight of copper present in coin B? Okay, right, and then what are we given? We're given the percentage of nickel, and we are asked the weight of copper. Right, that's fine. So now I'd be writing an A here and a B here. So what we've got a weight for coin A, which is 6.5 grams, and then we know that nickel is 25% of that. So then straight away from that we can assume that since there's only nickel and copper, we have 100%, the copper is going to take up 75%. So then in order to get the percentage of something, we're going to have to times it by 0.75. Then we can do that on the calculator. So we've got 6.5 times 0.75. We've got 4.875. So one important thing about quantitative reasoning that I didn't actually mention in the previous video is don't simplify anything unless it's like obviously a massive long number. See if it's something like 4.875. Don't simplify anything until the very end if you have to. So then for coin B, we've got 5 grams and we have 16% of nickel. So what I would do quickly, just so that my maths is not going to be like a stupid mistake which will throw me off, I'll do 100 minus 16 for the percentages. So we've got 84. So then we've got to times this by 0.84 to get the percentage of nickel, of copper, sorry, that's in this coin. So then we've got 5 times 0.84, 4.2. Then we've got the two sums here. So then all we're going to have to do is minus one from the other. Since you are so pressured for time and things like this, what I would do is, it doesn't have to be a positive number. If you take away something that's bigger from something else, it's still going to give you the same answer. So I wouldn't do 4.875 minus 4.2. I've got the 4.2 in the calculator here, so even to save me like 5-10 seconds, I'm just going to minus 4.875. And then we can take away the minus if we want, it doesn't really make a difference. We've got the number here, 0.675. There, thank God that was there. D, yeah. So it's all about saving wee bits of time whenever you can. Right. A group of, what question am I on? 13. I'll get to 15, or I'll get to the end of this, or 16, whatever it'll be. A group of people were asked to taste some paper soaked in a weak solution of PTC. The table gives some information, right? So we've got women, men, girls, boys can taste this and cannot taste this. This looks fine again, there's not too much information. 3/5 of women who can taste this and 7/12 of men who can taste this do not drink coffee. Okay, what percentage correct to 1 decimal place of adults? Okay, so that's assuming women and men are together. Who can taste PTC do drink coffee. Okay, so we've got the number of people who don't, so then obviously we're just going to have to find the opposite of that. So we've got 35 women. So I'd write that on the bottom of the fraction. Then we've got 3/5 of women who can taste it, don't drink coffee. Okay, so then 3/5, so 5 goes into 35, 5, 10, 15, 20, 25, 30, 35, 7 times. So then we've got 3 times 7 is 21. So we've got 21 of the 35 women. They can taste the PTC, so I would write things shorthand like this. Who can taste the PTC do not drink coffee. So now we do something like that. So therefore from that, we've got 35 women. 21 of them do not drink coffee. So then we've got, what's that, 14 of them do drink coffee. So 14 out of the 35 therefore do drink coffee. Okay. Then we've still got the men to do. So of the men in total, there is 72 on the bottom. 7/12 of them don't drink coffee. Okay. So usually what they'll do in something like this is, you can see that both denominators of the fraction will have like a common what's it called, a common denominator, so 12. 12 will go into 72, so it's, what's it, 12, 24, 36, 48, 60, 72. So it goes in 6 times. So then we can do 7 times 6 to find the number of men that don't drink coffee. So 7 times 6 is, 7 times 7 is 49, so 7 times 6 is 42. If you do need to brush up on your mental math, do it. I used my fingers in the exam to count. I'm absolutely no shame in doing it. If it helps you, it helps you. It doesn't matter. So then we've got 42 out of 72 men can taste this PTC chemical, therefore don't drink coffee. Then again, to find the difference is just 30. So 30 of the 72 and 14 of the 35 do drink coffee, so 14. So then on the top we've got 44 because we're doing the 30 plus the 14, and on the bottom we've got 107. 44 over 107, now it's calculator time. 44 divided by 107 is 41.1%. I'm writing this down just for a visual thing, but you obviously wouldn't in the exam. Another thing I wouldn't do in the exam is if you've got 0.4112, you don't actually need to times it by 100. You can see the number, like the number's there regardless, just move the decimal point in your head. Obviously if I'm going times 100 on top of that, it takes another 5 seconds, then I read the answer again. 41.1%. Let me just check that's right. Yeah, B. Okay. Right, we've still got this to go. So, if 10% of the men, I shouldn't have rubbed this out. That's another tip that I would say that I've actually just not even followed my own tip, but hey ho. If you have the same question coming up, I'd say, or if you sort of skip the question, don't rub it out until this question set's gone, because I've rubbed this out. It could potentially have information that I would use again, if you know what I mean. So I've done that, but we can live with it anyway. If 10% of the men who said they cannot taste PTC, so 10% cannot, so we've got we've got 60 men who said they cannot taste PTC could in fact taste it at higher concentrations. So we've got 60 men who cannot taste PTC. 10% of 60 is obviously 6. Then we've got 6%. We've got 6 men who can taste it at a higher concentration. What would be the ratio of men who can taste PTC? Who can taste PTC? So that's the top line. So we've got 72 on one side of the ratio to men who cannot taste it at a higher concentration. Okay, so then we've got 6 men that can taste it at a higher concentration. So then we've got 60 minus 6 is 54. So we should have 72 to 54 on both sides of the ratio if I'm doing this right. I think the wording is a bit tricky, but I think I'm doing it right. 72 over 54, so then you should be able to divide it by something. They will have something in common. Can you divide 72 by 2? You should be able to. 72 divided by 2. 36, no, there's no 36 there. Divide it by 3. 72 divided by 3. So maybe 24, is 24 an option there? Nope. Divided by 4, so we've got 72 divided by 4. 18, there's no 18 there. 72 divided by 5. 14 by 4, nope. 72 divided by 6. 12, nope. Notice how I'm referring both to the answers and to the calculator at the same time, because the answers there are giving me, if I'm doing this right anyway, I think I'm doing this right. The answers can pretty much help me through the question by referring to them. Let me just see if these divide by anything in common. 54 divided by 2 is 27. Okay, so it could be B, but then there's 72. At this point in the exam I would be getting stressed because I know that I'm halfway through a question, I've wasted time, I want the answer, but I am taking ages on it. So to be honest, I would probably just guess B at this point because I've got one of the answers through dividing something by 2. 72 divided by 2, 36. Okay, I would have said B. The correct answer is B somehow. I don't know. So that's what I mean by sort of guesstimating. I mentioned that quite a lot in the quantitative reasoning video. Just guess things. most of the time, if you have done something right, if you have an answer on your page that you've worked for and you know that the working you've done is correct, because a lot of the stuff you will know is correct if you've done it yourself and you know that your logic is sound. I know that throughout this my logic is sound because I did the 2 steps of the question. I found 10% of this, and I minused it off that, and I can take one thing from the graph, which is 72, and then get the other answer from here. I know therefore I've got the ratio here, so if I can get one of the numbers to sort of match up with the ratio, it would be right. So that's how I guessed that, to be honest. That might actually I think that might even be a typo in the thing, because we are dividing it by 2, so it should be 36. But anyway, I got that right somehow. So a population of 100,000 people is equally divided between men, women, boys and girls. Right, so straight away that's part 1 of the question. We've got a population of 100, so then divided by 4 is 25,000. So 25k, 25k.
No, 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 no.
I've done this wrong. Right, so at this point I know that I've done something wrong. I'm not even going to cut this out because this is actually what people need to see in the exam. If you realise you've done something wrong like this and it is a long question, I even knew it at the start. I knew something was just like, it was a big question, it was lots of places that I could make mistakes. Just skip it. I'm not going back to something like that. Actually, sorry, what I would do and what I should say is just guess it. I'm going to guess B for the entire exam because, as I've said as well, statistically, if you guess B throughout the entire exam, you're more likely to get something right than guessing, say, like A or whatever. Correct response is E, that's fine. Of the adults in the group, what percentage can taste PTC? So of the adults, so we've got men and women. This is quite similar to what I did in the previous question that I got wrong. So again, we've got 35 over 55 for women. Then we've got 72, what did I say, 130. Again, this is why you shouldn't rub stuff out. 132. So then we're going to add this together. I'll just do it in my head. We've got 55 and 132, so that's 187. And on the top we've got 107, I think. 70 plus 30 is 100, 5 plus 2 is 7, yep, 107. So then on the calculator we've got 107 over 187. 57.2%, 57.2%, C, right. Right, so I'm going to leave that there now. I'm keeping all of this in. Even the question I missed wrong, I got wrong, and even the questions I've missed, because it is important just to do it. Do the questions. If you feel like you can't do them, just skip them. It's not that big a deal. Okay, I'll end the exam there. Again, if you have any other sections that you'd like me to cover on this sort of like walkthrough thing, I can do it. Again, I sat the UCAT a year ago, so I'm not really up to scratch. This is the first time I've done quantitative reasoning in a year since my exam. But some of it does stay. So if you want any other sort of sections like QR, DM, situational judgment, anything like that, if you do want that, or if you want more on quantitative reasoning, more on abstract reasoning, which I've got another video on, just let me know for that. But yeah, thank you for watching, and I will see you in the next video.